Hi, welcome back to section 12.1. The next thing that we're going to talk about is inverses of a function. So let's talk about inverses. If the point xy belongs to a function, we're just going to call it f of x, then that inverse function in the notation, it looks like a -1 power. It looks like f to the -1 of x. That is the notation for inverses. So that inverse function would contain the point yx. So all that happened is the x and y switched places. Okay, so the inverse is formed by interchanging x's and y's. All you're doing is switching x's and y's. So that also means if you're thinking about the domain of your original function is going to be the range of your inverse. And the range of your original function is going to be the domain of the inverse. Okay? And that inverse is only a function if f of x is 1 to 1. So because you're switching x's and y's, it basically needs to pass that horizontal line test for that inverse to be a function. So let's do a couple examples where we determine, first off, is it 1 to 1? So can we actually do this? And if it is, we're going to find the inverse. Okay? So the first one is just a set of points. I think that's good to demonstrate. So first function is the function f, and it contains the points 2, 5, 3, 6, 4, 8, and 8, 7. Okay. You can see some of those. Here we go. So is it 1 to 1? All right, well, every single x value, 2, 3, 4, and 8, they just go to one y value. 2 goes to 5, doesn't go to anything else. 3 goes to 6, 4 goes to 8, 8 goes to 7. We don't really have any duplicate x's. We also don't have any duplicates of the y values, 5, 6, 8, and 7. So 5 goes back to 2, 6 corresponds with the x value of 3, 7 goes with an 8, and 8 goes with 4. So we don't have any duplicates, which is kind of nice. So it is a 1 to 1 function, so we can find the inverse. Hooray! So the inverse, again, you use that it looks like a -1 power, but that's the notation for inverses, okay? So to do the inverse, we're just going to switch x's and y's. So instead of 2, 5, guess what we're going to have? We're going to have 5, 2. We're just going to switch them. So instead of 3, 6, guess what we'll have? 6, 3. Instead of 4, 8, we'll just switch the x and y and get 8, 4. And instead of 8, 7, we're just going to switch them around and get 7, 8. That's all you do, and we're done. Okay? In part B, we do an equation version, so that's kind of nice to have an example of as well. So I started out with the function f of x equals x to the third plus 1. So I guess the question first is it 1 to 1? So for every x value, does it just go to 1y? So if I substitute any x value in, I would raise it to the third power, which is just going to give me one answer. Then I'll add 1, which will just give me one answer. So yes, it only goes to one y value. How about if I start out with a y value? So that's the f of x. If I started out with something over here in the f of x, and I wanted to solve for x, I would probably subtract 1 first, which would just give me one answer. And then I would take the cube root, and it's not the plus or minus cube root. Remember, cube roots of negatives gives you negative answers. Cube roots of positives gives you positive answers. So you don't really have that plus or minus thing going on with cube roots. You just get one answer. So we'll just get one x value. So checks on both. It is 1 to 1. All right. So let's find the inverse. So to find the inverse, all you do is switch the x and y. I know that the y right now is kind of disguised in function notation as an f of x, but that's our y right now. So we're going to put an x right where the y was, and I'm going to put a y where the x was. Okay, that's our first step. Then I'm just going to solve it for y so I can get it in that function notation again. So to solve for y, I'll subtract 1 from both sides. And then to get rid of the third power, I'm going to take the cube root of both sides. So remember, the third power and the cube root, those are opposite operations. We'll just have a y on the right side. And there's not much I can do for simplifying on the left side. It's just the cube root of x minus 1. Then I can get it in that function notation. Instead of a y, I'm going to use the f inverse notation of x. So there's my inverse function, and it's going to equal the other side, which is the cube root of x minus 1. So that gets us into that inverse function notation. Now it's your turn. You all get to try one and show me how much you've learned.